Good afternoon, everyone. This is going to be a pre-recorded video for your module PN4035, Process Technology 3. Now, in this video, what I want to do is to give you a quick run over of SolidWorks sustainability, and in particular, it's the application sustainability within the SolidWorks package. Now, everyone should have this sustainability application available within their SolidWorks. If for whatever reason you cannot find it, please let myself know or your TA, and we'll be able to provide you with some support to find that application within your SolidWorks package. Now, this could be an issue with the particular SolidWorks package that you downloaded, but if you were to follow the instructions provided to you at the start of the semester, this should not be a problem. Okay, so to kick things off, this is going to be all related to your final section of your portfolio of the environmental impact analysis. Now, we've yet to go over the material analysis, which we'll do in week 8, but for this week, week 7, I'm just going to give you a bit of a demonstration or tutorial on how to use the sustainability package in SolidWorks to tackle this environmental impact analysis. Now, this environmental impact analysis is going to be in relation to your final solution for the conveyor belt project itself. The SolidWorks sustainability application provides you with a number of different, tools in which you can evaluate the sustainability of your design itself. Now, what I like to do is I like to use the scroll saw and the various components in that to run through the sustainability application. But this is, obviously applicable to the project that you're completing, although it'll be different materials as well as a few more components than you typically see in this. Now, does this have to be a catch-all? Absolutely not. Not all components will have to be included in this. Like, for instance, if you have motor, screws, and so on, they don't have to be put into this. Although it won't be a perfect analysis of the project itself, it still gets you a bit of an idea how this application can be used in a variety of situations to basically make a report and to deepen your understanding of sustainability for design. So basically, it's an application within the SolidWorks suite itself and should be available within SolidWorks. So what we can do is we can just open up the scroll saw itself, as you can see here. I'm just going to close that down. No. So this is basically an assembly of the scroll saw. Now, last year, what you would have done is you would have analyzed using this application the actual arm itself. So it's an individual component. For you, what we'll have to do is analyze the full assembled project. Before doing that, one thing you'll have to do is have to travel through your project and apply the materials to each of the individual components. So for instance, the base of the scroll saw was mild steel, so we had to apply mild steel to that. The sides, as you can see here, left and right, are aluminium. Then we have our central arm, which is aluminium. And then we also have mild steel shafts in between holding plates, and we have brass bushings. Now, we have a variety of other materials, including whatever you used for the blade itself and the type of hardware you use. Now, these hardware could be stainless, or they can just be mild steel or some variation. Now, I'm not going to be too bothered about everything in this particular project. For instance, the screws, the hardware themselves, I'm not too bothered about them. If you'd like to include them, absolutely fine. You'll just have to apply a material selection to that. To do that, you can just go to your Appearances tab here on the far right-hand side, and you can basically apply whatever appearance is appropriate for that particular material. So if it's metal, you can go down to metals. You can go to aluminium if it's aluminium, and then choose the particular aluminium it is. SolidWorks will then apply that to the individual component so that it knows what that component is made out of for the sustainability analysis. Okay, so to analyze this particular assembly, what we can do is we can go to our evaluation. So usually when we come into this, it's usually in this assembly tab. We move over to evaluation, and we come all the way across till we see sustainability. It should be here. If it's not here, you could also find it within your options, and you can add it in or find it in your add-ins itself, as you can see here, and you can just click on it, ensure that it's there and available. But it should be readily available here. So we click on that sustainability, the application should open up, and what we can do is we can start identifying what each of the materials are if we haven't already done so. So for instance, if we click on sustainability here, because we have already identified what the materials are, it won't get us to do that now. But for instance, if I close this down and I don't save, say no, and I open up that assembly again, see here now, builds. Just going to make these non-transparent, which they are at the minute. Okay, so we just have our solid object. Okay, I had them transparent so you could see through the object itself. So if we go back to our sustainability, you can see that it has a few issues. Okay, this is more likely what you'll have as well. It basically tells me that these individual components that are left here, which are all my hardware, I haven't identified what material they are. So I can actually click on them and I can select a material that reflects that particular item. But because this is hardware, I'm just going to exclude them from my analysis. So if we open up this here, and I'm going to say exclude all of these components, I'm going to exclude, yeah, so all they're excluded now, so they're not going to be taken into consideration for our sustainability output. What I can do now is I can also, I can just go in here and I can say review or view results, because all the other parts that are important to me have their particular appearances assigned. Now, we need to put in a few bits of information. So it's basically asking me, where is this assembled? So this matters for sustainability. So if it's assembled in Europe, or if it's assembled in Asia or America or wherever else, it impacts the sustainability of the design. So for instance, if it is assembled in, let's say, Asia, and it is used within America, then you're obviously going to have to factor in the transport between those two different locations. For us, because we'll say that this is going to be a typical scroll saw manufactured to be sent out to schools around the country. So let's say this is an official scroll saw that they'd use, let's say, in a woodwork room. We're going to say that it's more likely manufactured, assembled within Asia. Okay. How long are we going to say it's going to last? So if this is a proper scroll saw, we're going to say that the duration of this, when tested, it runs for about 10 years on and off in our particular application before it has to be replaced. Okay. Now we're going to say that that's 10 in years, not months or days. For instance, if this was a wearable component or wearable assembly that was a sub-assembly of, let's say, a conveyor belt system used in a mine site, this might be days or months rather than years. But for this particular assembly, we're going to say it's 10 years in duration on average. We're going to say that the fuel type used within the assembly process is going to be electricity, not natural gas, sorry. I'm going to leave it at its estimated amount. Then I'm going to say where it's going to be used. Okay, so this is going to change things dramatically. If I said Asia, it's obviously going to have less of a footprint than it would if I said, you know, somewhere like North America, Europe, South America, Australia, or India, because there is obviously a travel distance, a larger travel distance between those two different locations. Let's say this is going to be used in European schools. So we'll go for Europe. Now, if you knew exactly where it had to go, you could specify what type of transport it would be using and what the distance is. We're just going to use the estimation provided here and the most likely form of transport. The most likely transport between, you know, Asia, so places like China, to Europe, technically, you know, or typically for an item like this, it's going to be shipped by it's going to be transferred by boat. The reason for that is because it's the most sustainable way in comparison to rail, truck, or airplane. Now, if this product was needed to be delivered rapidly, obviously you'd have to go for a different form, typically for airplane, but because it's a scroll saw, it's typically heavy, we're more likely it's going to be shipped over by a ship itself by sea. It's going to give us an average kilometers for an average location in Asia all the way over to Europe. If you want to specify in particular the distance, you can put it in. I like to leave it as estimated. Here we can also see the end of life. So for the particular materials used, it's estimating that 89% of this is recycled. It also identifies that 11% that has to be incinerated, and that 0% of it ends up in a landfill. Now, what I would say is more than likely, what will end up happening here is that 90% of this is going to be recycled, and then there's going to be waste material, as there always is when smelting. So that's slag, particularly on the top, and we'll say that that's going to actually have to end up in a landfill because that can't be smelted, because it's not material that can actually be used to, let's say, power, let's say, an incinerator. So incinerators are usually used to produce power in countries by burning off rubbish and gaining back some of that energy and using it elsewhere. So it's not just sitting in the ground. So we'll say that this particular material, because none of it is flammable, it's not going to produce, it's going to use more energy than it would be worth to actually to incinerate it. So we're going to say it's 0% incinerated here, and then you can see that the remaining 10% is going to go to the landfill. So that's the excess spillover, or it's going to be the slag or whatever else waste material is left in the process. As you can see here, once we have all that information filled out, you're going to have a bit of a breakdown of the impact by carbon, energy, air, and water. You can also click into each of these and you can look at them in more detail in relation to this project itself. This is going to vary depending on your particular project. If you click into one of them and you want to go back, I'd go back to this home button here, and you can then, let's say, click into different like water, or you can click into carbon. Okay. Now, what's important when you get to this point and you have that information filled out is that you can go down here to the bottom right hand side and you can save a report. And what I'll do, it'll produce a report on your particular project, as long as you have everything specified right, the right materials, and you know where it's going to be manufactured, where it's going to be used, and you can make this report. You can actually save it as a Word document, as you can see here. You can give it a name and a file location. I'm going to say this is perfect. I'm going to go with that. I'm going to replace one that's there. Then I give it a few seconds. It's going to put together that report, to accumulate that report, and we'll be able to have a look at it. Okay, perfect. So as you can see here, it generates this bit of a report on the project itself, gives you a small bit of pictorial view. In this case, it's an isometric, as well as it highlights where it's being manufactured, where it's also being used afterwards, the weight of it. You know, it calculates this from all the different materials, the time that it's going to be used for, and so on and so on. You also know if there's going to be information missing, which you can fill in yourself. And as you work further down, it gives you a small bit of breakdown depending on all those different sections. It's going to look very different for you, but I would like you not just to hand this up as that particular section. So let's say go back as your environmental impact analysis. That is not going to be good enough just handing up this document. You're going to need to add to this document, so I would delete any redundant information. I would fill in any information that is still necessary. So company logo here, you don't need any of that. Company name, you don't need any of that. Maybe your own name, your own ID. Obviously, this is done individually. You need to identify all this other information. But then what I would do is I'd have a brief description or discussion about each of these individual elements. So for instance, if it's talking about the manufacturing region, I want you to identify where this could typically be manufactured and why you've chosen this particular location. And then talk about, you know, where it's used, the distance between them, and so on and so on. So I want to basically have you break down this information yourself by engaging with this and other sources to give further explanations of what actually is being said here. Like, for example, when it talks about here the carbon footprint, the total energy consumption, I want you to give a bit of a summary, identifying what this means and what all these different sections mean in relation to your project. I want you to show me that you understand what is actually being said here within this document. If anyone has any problems with engaging with this, please do contact me. I'll be able to point you in the right area, but there is going to be a lot of independent analysis of this information and referencing different sources to ensure that you yourself are actively engaged with this task and you know, outputting high quality analysis of the sustainability of this particular product that you manufactured.